now recording. All right. Conditional probability. We're going to just go back on last lesson's notes on addition rule. And then I'm going to try to bring into the concept of what you've been learning since year 7. Tree diagrams, tools, probability, and how it links to conditional. So let's start off just refreshing our memory with Venn diagrams and conditional maps, 2 of our common tools to solve problems. So right now I'm going to just give you the scenario. Say we have 20 people in the class and 15 people are wearing jackets. Let's call it A instead of J. So event A or set A is the number of people wearing jackets. Set B is the number of people wearing hats. And then 5 are wearing both a hat and a jacket. Fill in the table. Give you 1 minute, 60 seconds. Let's go. Sorry, when I started the session and I told you to fill this table and I paused the video. So I paused it and I never resumed. So pretty much from here onwards, hopefully you were listening to me. Otherwise, I'll put in my year 11 videos and you can watch my year 11 explanation. Same idea. Just different notes. All right. Let's do an example. So that was a lot of theory. Let's do some examples just so you get the feel of how to solve it, okay? All right, so if you didn't understand the theory that I was trying to describe, just memorize that formula, okay? This one formula that you have here, that is essentially what conditional probability exercise will do, but I want you to understand the theory because then you can apply it, okay? So here we go. Let's go to this example here. Example 1. From a group of 23 people who go to the movies, 13 bought popcorn, 15 bought Coke, and 9 bought popcorn and Coke. So let's fill it in. 9 bought both, so 9 goes here. There's meant to be a total of 23. 15 bought Coke, so 15's over here. And 13 bought popcorn. So what does that work out to be? This should be 4. This is 8, that's 4, 13 plus 10, and so this should be 6. All right, cool. I filled out the table. Remember, cardinal maps are best for calculations. So I filled out a table. First question, find the probability that the person only bought popcorn. So if they only bought popcorn, means popcorn and no Coke. Here we go, 4 people bought popcorn but no Coke. So probability of P and not Coke is equal to 4 out of 23 people. Okay, so far so good. Second scenario. Thank you. B. Find the probability that the person bought popcorn given that they bought a Coke. So you already know that they bought Coke. So looking at this diagram, they already bought Coke. So that's the one thing you know. It's not out of 23 people anymore because some people didn't buy Coke. But in this case, we know they bought Coke. There's only 15 that bought Coke. So that means probability, I know that they bought Coke. So it's given that they bought Coke. It has to be out of 15. And I'm asking, what's the chances of those 15, if I had to pick one randomly, what's the chance they bought popcorn? Those are the only people that bought popcorn. There's 9 of them that bought popcorn and Coke. So it should be 9 out of 15. And that's my notation. How does a formula work? Let's say you couldn't do that intuitively and you couldn't see it through the cardinal maps. Well, the rule would then have been this. It would have been chances of popcorn and Coke divided by the probability of getting Coke. Now, if you want to work about individually, what's the chances of getting popcorn and Coke? What's the chances of getting popcorn and Coke? Look at the table. 9 out of 23. So the 23 people, what's the chance of getting someone that's getting on a popcorn and a Coke? 9 out of 23. But then what's the chance of getting someone that a Coke? That bought a Coke? Out of 23. 15 out of 23. Can you see now, if you put them both together, isn't it just 9 over 23 for the top numerator divided by chance of getting someone that has bought Coke is 15 out of 23, but fraction on fraction really just means 9 on 23 divided by 15 on 23. When you divide fractions, reciprocal and multiply, so you can see here, it actually ends up cancelling out. 23 divided by 23 cancels out, and you get 9 on 15 as well. This is how most year 11s would do it. I do it intuitively because I understand from the table, so you should get 915 straight away, but if you did it, you can still calculate through the formula to get there. I'm going to pause the video and remind me to resume. Have a go with C. I'm going to pause the video. I want you to find me the chances that the person bought a Coke given that they bought popcorn. Whoops, I forgot to record again. Here's the answer. 9 out of 13. Now I want you to do this year 11 problem. Same thing, model it. Draw a tree diagram as a hint. Pause the video. Alright, it's recording again. So here we go. 3, 2, 1. Draw a tree diagram first. So hopefully you got this. Usually at year 12 you get 1 mark just to even set it up. Okay? Now I'm using M and T. M for Monday raining.
Isn't it 0.17, not 0.07?
Wait, what was it?
Not raining on Tuesday, Monday, and then not raining.
Yeah.
This one. Oh, my answer's wrong.
We did something right.
Thank you. Oh, I gotta fix my answers. Alright. Eyes and ears towards the board. Thank you. Thanks, team. Thank you. Alright, let's go through. Can I get a show of hands who at least modeled, you don't have to use the same letters as me, but at least you modeled the 2 scenarios. Hands up if you got that. Okay, good. That's the first step. So this is saying, first event, raining, not raining. Tuesday, rains depends on the previous. So the scenario already kind of hinted to you, it's a given conditional probability. Tuesday dependent on what happens on Monday. So you got 2 scenarios. If it rains on Monday, then there was an 83% chance for Tuesday. If it doesn't rain on Monday, then there was a 30% for Tuesday. I filled out the missing probabilities because if it rains 21% of the time, then there's 79% chance that it doesn't rain. Thank you. And Tuesday, same thing. If it's 83% chance if Monday had rained, then that must mean there's 17, not 7. And if it's 30 for the scenario where it did not rain on Monday, then it must be 70% chance of not raining on Tuesday. So this is the first key setup. Now known as conditional, remember this is not T. This is actually T given M. Each of these second branch is a conditional situation. So the first question said, what's the chances of it raining on both Monday and Tuesday? This is what you're looking at. Raining Monday. Raining Tuesday. So the chances of getting Monday is 21%. And then to get Tuesday, there's 83% chance of the 21% chance. So of means times. So the first one should be
Maybe.
probability of Monday raining and Tuesday raining should end up being Monday times probably Tuesday, given that you got Monday raining, is 0.21 times 0.83, 0.1743. Can I get a show of hands who got the first part correct? Okay, well done. So the first part, drawing the diagram. Second one's interpreting the information. Second one, I made a mistake, so I've got to fix the answer. Here we go. 3, 2, 1. Next one. So, my mistake was it should have been... Oh, it didn't actually affect it, did it? No, it didn't. Okay. Because that Tuesday not raining didn't affect it. Now, when you're looking at my calculations, The question says raining on Tuesday. This was not the only Tuesday that it rains. This is also another Tuesday that could rain. So that means there's two scenarios there. There is the scenario that it doesn't rain on Monday, but it ends up raining on Tuesday. So that means you have to work out the chances of both. This one you just did. This one's the missing one. So how do you find out what's the chance of not raining? 79% chance. Tuesday raining if that happened. 30% chance, so 30% of 79. That's what I'm doing here. I'm saying that's Monday raining, Tuesday raining. That's how Tuesday would rain. Or, so the plus, or it could have not rained on Monday, but did rain on Tuesday. That was 0.79 times 0.3, or 30% of the 79%. Adding these two scenarios together gives me the total chance of it raining on Tuesday, which in this case should be 41%-ish, based on that scenario. Okay? I'm going to stop that there, but that is the type of Year 11 questions that you would practice. If you're feeling confident, move there. Otherwise, stick with the Year 10 curriculum, which is your Carnal Maths. Okay? I'm going to start the video there. Thanks, team.